In this video, we're going to be looking at the second type of vector product here called the cross product. Before we get started on that, we want to talk about a determinant of a matrix. So here we have defined the determinant of a 2 by 2 matrix and the determinant of a 3 by 3 matrix. The determinant of the 2 by 2 matrix ABCD is AD minus BC. So we take the top left and bottom right values, we multiply those, and then we subtract off the bottom left times the top right. And that's how you calculate the determinant of a 2 by 2 matrix. The determinant of a 3 by 3 matrix is A1 times the determinant of what's left over if you cross off the column and the row that A1 is in, right? And what's left over is this B2, B3, C2, C3. So we take A1 times the determinant of B2, B3, C2, C3, and then we subtract, and it's very important here. You notice this is a subtraction now. We subtract A2 times the determinant of what's left over if you cross off that row and column. So what's left over is B1, B3, C1, C3. So we take A2 times, we subtract A2 times the determinant of that. And then we add A3 times the determinant of what is left over if you cross off the row and column that A3 is in, right? Which is the B1, B2, C1, C2. part. And the specific formula of what that all turns out to be, if we apply our formula for each of the 2 by 2 determinants, then we get this that I've circled here. You'll be able to use your notes for any homework or tests, so you don't really need to memorize these formulas, as you'll always just be able to have them in front of you for this class. So yeah. That is it for talking about the determinants for right now. Those definitions may be weird, but the reason why those are defined that way are a little bit beyond this class. So for this class, just believe or understand that we have defined the determinant in that way, and we will see what that can do here in a few minutes. But for now, we'll just take some practice get some practice at actually calculating these determinants. So let's do that here. Let's do the determinant of this 2 by 2 matrix. So the determinant of 1, 2, 3, -1 is 1 times -1 minus 3 times 2. So this is -1 minus 6, which is -7. And that was simple. And 2 by 2 matrices are pretty simple to find the determinant of. It'll take a little bit longer to apply the formula for a 3 by 3 matrix here. So let's write that out. Determinant of 1, 2, 3, 2, 4, 1, 3, -1, 2. This is 1 times the determinant of what is left over if you cross off the column and row that 1 is in. So this is 1 times the determinant of the 4, 1, -1, 2 matrix. Right, it's this one. So what is that? Well, that is 4 times 2. Minus 1 times -1. And then we want to subtract off 2 times the determinant of what is left over when we cross off the row and column that 2 is in. So that would be crossing off this and this. Well, we see what's left over is the determinant of 2, 1, 3, 2. So that is 2 times 2 minus 1 times 3. And then we add 3 times the determinant of what is left over when we cross off the row and column that 3 is in. So this is 2 times -1 minus 3 times 4. And then we do all of this calculation. So we get 1 times 8 minus -1 is 9. Then we have minus 2 times 4 minus 3 is 1. Plus 3 times -2 minus 12 is a -14. So it looks like here we have 9 minus 2 minus 42. So 9 minus 2 is 7, and 7 minus 42 is a -35. And that's it for calculating determinants. Really quickly, we will define the cross product and then do a couple of examples with that cross product. And that'll end this first video on the cross product. So how do we actually define the cross product? We define that to be the determinant. So, for the cross product of any three-dimensional vectors, A is the vector A1, A2, A3, and B is the vector B1, B2, B3. For the cross product of those two three-dimensional vectors, we define that cross product to be the determinant of this vector ijk up at the top. Remember, I, j, and k are the standard basis vectors in the x, y, and z direction, respectively. Those are unit vectors in those particular directions. So we take the cross product of, the cross product of A and B is the determinant of the vector ijk in the first row, the vector A in the second row, so that is A1, A2, A3, and then the vector B in the third row, so that is B1, B2, B3 in that third row. This reduces to I times the determinant of, the vector I times the determinant of A2, A3, B2, B3, minus J times the determinant of A1, A3, B1, B3, plus K times the determinant of A1, A2, B1, B2. Which the final formula is written either here, or if we recall, this is equivalent to this notation on vectors. So we just apply this formula to calculate our cross product. Now, one thing to point out is the dot product was a product of two vectors that resulted in a scalar. The cross product here is the product of two vectors that results in a new vector. And we'll talk a little bit about the properties of that new vector in the next video on cross products. But for right now, just recognize that the cross product does result in a vector. And now let's do two examples where we actually calculate this cross product. So we want to take the cross product of A and B here, where A is 1, 2, 2. We want to cross this with the B vector, which is -2, 3, 1. This is the determinant of the vector I, j, k, and then 1, 2, 2, -2, 3, 1. And now let's actually calculate that. Well, this is, in the first quadrant, let's calculate A2, B3 minus B2, A3. So A2 is 2, B3 is 1. We subtract off B2, which is 3, times A3, which is 2. And then we have in the second coordinate, subtract a1b3 minus b1a3. a1 is 1, b3 is 1, minus b1 is negative 2, and a3 is 2. And then our third coordinate is a1, b2. a1 is 1, b2 is 3, minus b1 is negative 2, a2 is 2, and then we just calculate all of that. So in the first coordinate, we have 2 minus 6, right? 2 minus 6 is negative 4. Then we have negative of 1 minus negative 4. 1 minus negative 4 is positive 5, but then we have a negative out in front, so that is a negative 5. And then we have 3 minus negative 4. So 3 minus negative 4 is 3 plus 4 is 7. And that should end that example. We have negative 4, negative 5, 7 there. And let's clear that out and do the other example. The other example is B cross A. So this is the determinant of I, J, K. And now we have B in the second row, excuse me. So negative 2, 3, 1, and 1, 2, 2 in the third row. Okay, let's do this here. We get A2, B3. All right. A2, B3, so this is 3 times 2, minus B2, A3, 2 times 1, comma, negative. All right, then we get negative of the determinant of the thing left over when we cross off the column and row that J is in. So that is negative 2 times positive 2 minus 1 times 1. Close that parentheses, comma. And now the third coordinate is the determinant that's left over after we cross off the row and column that K is in. So this is a negative 2 times 2 minus 1 times 3. And then close that bracket there. That is supposed to be an angled bracket. Sorry, I ran out of room there. Okay, put all this stuff together. And we get first is 6 minus 2 there is positive 4. And then we get a negative 4 minus 1 is negative 5, but we take the negative of that. So that is a positive 5. And then in the third coordinate, we have negative 4 minus, that is a 1 times a 3 here. So negative 4 minus 3 is negative 7. And so we get the vector 4, 5, negative 7. What I would like to point out is A cross B was the vector negative 4, negative 5, positive 7. B cross A is the vector 4, 5, negative 7. So we notice that they are the negatives of each other. So A cross B is equal to negative of B cross A. That was true in this example, and it turns out that is always true. All right. So that's where we will end this video.